Hello everyone, my name is Rohit Singhal and today we are going to discuss the topic hydrocarbons. So, hydrocarbons. Now, first thing is ki why do we need to study this topic, what this topic means and what are the its daily uses in our life. So, hydrocarbons, these are the important sources of energy, important sources of energy. For example, LPG. LPG that we use in our daily household for the cooking purposes, CNG which we use as fuels, kerosene oil. These are few examples of the mixtures of hydrocarbons which we use in our daily life as an important sources of energy. So, if we broadly discuss what hydrocarbons, how we can classify it and what we need to study in this. So, hydrocarbons are broadly divided into two categories. The two major categories of hydrocarbons are, one is saturated and another is unsaturated. Saturated, what do you mean by saturated hydrocarbons and unsaturated hydrocarbons? So, saturated hydrocarbons means there is a one C and single bond C, and whereas unsaturated hydrocarbons means there is a C double bond C. Hydrocarbons normally, as we know, that these are the compounds of carbons and hydrogens, carbons and hydrogens. What is the valency of carbon in general? Carbon is a tetravalent species. That means carbon can be bonded by the 4 other atoms. It can be hydrogen, it can be carbon, it can be oxygen, it can be nitrogen, it can be anything else. Similarly, hydrogen is a monovalent species. That means hydrogen can be bound to only one atom. It can be carbon, it can be nitrogen, it can be oxygen, it can be anything else, but it will only be binding to one atom. So, what are saturated hydrocarbons? Let us discuss first about this. Saturated hydrocarbons, as I already told, they are C single bond C. Okay. So, now we know that the carbon has a tetravalency. So, we need to have 3 vacant sites to fill. These as we are talking about hydrocarbons. So, these 3 positions will be filled by the hydrogens only. There will be no other atoms, at the hydrocarbons are the compounds of only carbon and hydrogen. So, something like this. So, saturated hydrocarbons, these are called alkanes. What are they called? Alkanes. Do specify on the name alkanes. So, alkanes, what are alkanes? The first the alkanes are a series of carbon and hydrogen bonds where there is a carbon carbon single bond starting with the initial compound methane, molecular formula CH4, methane. So, what is its structure? This is methane, CH. There is no other carbon. So, all the 4 valencies are shared with hydrogens. Okay. So, this is the first hydrocarbon or first alkane in the list. This is a gas. Methane is a gas, as we know, we already have studied about the methane gas. So, methane is the first member in the list, and it, as we know, is a gas found maybe found in coal mines or marshy places. Some found in coal mines. It is a poisonous gas though. So, what here is the carbon, all the 4 valencies of carbon are satisfied by the hydrogens. If this is the first member of the alkane list. If we need to go higher, what we need to do? We need to replace this one H by a CH3 unit. If we replace this by a CH3, so what will happen? C H H H, and this is replaced by CH3, where this CC bond will formation will occur. H H H, giving a formula of C2H6, and this is called as ethane, the second member of the list, and it is also a gas. Okay. So going further, what we have discussed till now, we have discussed what are the alkanes: CH4, C2H6. This is ethane, methane, propane is a third member of the list, and so on. We can go on. Okay. So now, if we talk about what are the structure of alkanes, let's talk about the structure. How? What are these structures? So I have already told this is our tetravalent species. So this is how actually we make a this carbon. In this methane, the bond angle between the hydrogen, carbon, and the hydrogen is, this angle is 109.5 degree. This goes with all the same thing. This is also 109.5 degree. This to 109.5 degree, means all the angles are same. Might not be visible in a 2D structure, as this is a 3D molecule represented in a 2D space. So it might not seem all the angles perfect. So we can make it as in a different way, like if you now see this 1 2 3. Now all the bond lengths, what is this? All the bond lengths, you might be aware of all the bond lengths are same. Bond lengths are same. Point number 1. Point number 2, all the bond angles are same. There is no difference between the two bond angles, as all the angles are between the hydrogen, carbon, and hydrogen, and this is of 109.5 degree. The structure is termed as, in scientific terms, it's a tetrahedral structure. Tetrahedral, and this shape can be also recognized as a tetrahedron. In mathematics, we normally take as a tetrahedron. This is a tetrahedron figure. Okay. So this is the basic structure of the methane. If we talk about what is methane. Now, if we talk about the structure of the higher members of the series, what we gonna say? Let's say structure of an ethane molecule. That means C2H6. So this, as we talk about, is carbon carbon single bond, hydrogen, 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 hydrogen. What was the difference between the structure of the methane and ethane? Is there is a one CC bond which was not there in the methane molecule, and as we know, but and this bond formation, all the bonds are, this is a sigma bond, and you must have studied in the previous classes. Sigma bond is an head to head overlapping. What is head to head orbital overlap? What is head to head orbital overlap? Let's discuss a bit more about that. So these are the orbitals. This is a carbon. It has one s orbital and 3 p orbitals, right? And 3 p orbitals. Okay. So and let's say one is bonded with this. So these are 3 p orbitals, and let's say one is the hydrogen bond. So this will be for the another carbon, hydrogen, hydrogen, hydrogen. Now these are the hydrogens marked in the black ones. Hydrogen, as hydrogen only have the s orbital. What? Carbon have one s and 3 p orbitals, whereas hydrogen has only one s orbital. So this is how the bonding occurs, and these are the hydrogens, 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 and this overlap, this head to head overlap, this head to head overlap of the orbitals make a sigma bond, and sigma bond is comparatively stronger, a strong sigma bond we can. Okay, yeah. So this is the structure of the ethane molecule. Now let's talk about what are the bond angles, bond distances, bond energies. So some properties of alkanes. So properties of alkanes, first we can say what is the basic formula of the alkanes molecules. What we have seen till now, the first molecule of the alkane series is methane. That structure is CH4, right? The second was one C2H6. This is an ethane. So the general formula this this alkane series have is CnHn plus 2, where n can be 1, 2, 3 and so on. As you will start forming this, you will keep one, it will form a C1H1 plus 2 and CH4, it will form a methane molecule. Then it will go on and carry on forming a C2H6 ethane, C3H8 propane, and the entire list and all the members of the analogous series can be formed. So the basic this is a general formula. So general formula for this series is this CnHn plus 2. What is the second thing? Let's talk about the CC bond distance. What is the CC bond distance? You must have already studied this. This is 154 picometer. The bond angle between H, C and H is 109.5 degree. What is the shape of the alkanes? It's tetrahedral. The hybridization it not might be much necessary for you guys, but if somebody asks, this is called sp3 hybridization. How it is not much of your importance, you will deal with in the higher classes, but this is the shape of the alkane molecules. Okay, the fourth thing, this is a homologous series. This forms a homologous series. What does it mean by a homologous series? Means there is some pattern. Means what is this means? There is some pattern followed in the members. What pattern does it follows? What is the structure of the first molecule? It's a CH4, right? Another one is C2H6. Another one is C3H8. So if you carefully see, there is an increment of something. C4H10. This is the general formula, right? And general formula is CnHn plus 2. With the help of this formula, you can form the entire series without even remembering the formulas. Okay, so what you see, the common pattern in all this series is there is an addition of one carbon. As one here we can see there is one carbon, there is two carbons. So addition of one carbon. How many hydrogens have been added? 2, CH2. Let's look at this. 2 carbons, 3 carbons. That means one carbon is added. How many hydrogens are added? 2, CH2. This is CH3H8 propane. How many carbon is added? 1. How many hydrogens are added? CH2. That means homologous series this alkane forms by as there is an increment of a CH2 unit in between the two successive members. There is addition of CH2 unit among the two successive members. Okay, so this is the fourth property. Fifth property, there is also one thing bond called bond energy. What do you mean by bond energy? Bond energy means the energy required to break a bond. So if we need to understand this bond energy, what the in simple terms this bond energy is. So bond energy is the energy required to break a bond. It can also be termed as the energy required to form a bond. If we need to make a bond or formation of a bond, we have to give the energy. That means it's an endothermic process. Giving energy to anything is an endothermic process. Means the heat is applied, the heat may be supplied or the energy will be supplied from the outside. Bond energy, if we talk about in the simple language, it's the amount of energy required to make a bond, or it can also be termed as the amount of energy required to form the bond. Whenever a bond is broke, it releases energy, and whenever we have to form a bond, we have to give the energy. So bond formation means bond formation giving the energy is an endothermic process, whereas bond breaking, the bond breaking means a molecule is breaking into the atoms and it will release energy. This is an exothermic process. So this is the bond energy. So what in CC bond is formed in the alkanes and its energy is around 350, roughly it is, not sure, it is 350 kilojoule per mole. So till now we have discussed about the basic idea of the hydrocarbons, what hydrocarbons are, how they are important in our daily life. We talked about its classifications, the unsaturated and the saturated hydrocarbons. Then we talk about the alkanes, where the CC where there is a CC bond present, and these are some few listed properties of the alkanes. We will further discuss its nomenclature or the unsaturated hydrocarbons in the later classes. Thank you so much.